Good morning, everyone. Welcome to our final project, which focuses on TMU soil management plan, where our goal was to develop a particular construction management strategy for contaminated soil removal, replacement, and foundation backfilling. The project area assigned to our team was 62,582 square meters, and one of the main challenges was dealing with contaminated soil while keeping construction efficient and environmentally safe. Because of this, we divided the work into two construction phases. Phase 1 focused on contaminated soil excavation in axes 8 to 12 and 16 to 25. The reason for dividing the project into phases was to allow earthworks to be completed first, then wait for foundation construction before final backfilling was started. In Phase 1, 60% of the soil from axes 8 to 12 was stored on site in a temporary storage area with a capacity of 22,305 cubic meters. This soil had a lower contamination, so it could be reused later. The remaining 40%, along with all the soil from axes 16 to 25, was transported to dump site 3 because contamination levels were much higher there. A total of 103,488 cubic meters of contaminated soil was removed, while 147,938 cubic meters of replacement soil was imported. This required 11,736 truck trips, using a fleet of 60 dump trucks operating continuously. Phase 1 lasted 59 working days, from May 4th to July 20th, 2026, and involved 218 workers. The total cost of Phase 1 was $17.9 million. After Phase 1 was completed, temporary haul roads and work areas were removed, and the site was handed over to foundation construction, including concrete columns and beams. Phase 2 started after foundation work was completed. The goal in this phase was foundation backfilling using a 50-50 blended soil mixture. Half of this mixture came from the stored soft soil from Phase 1, and the other half came from important replacement soil. The blended material was stored in a second temporary storage area with a capacity of 44,542 cubic meters before replacement. Due to foundation spaces being too narrow, Phase 2 became more labor-intensive rather than equipment-heavy. This phase used 70 construction workers for filling and compaction with a total workforce of 225 workers. Phase 2 lasted 23 working days, and the total cost was $9.72 million. Overall, this project showed that successful construction management depends on combining scheduling, soil logistics, resources planning, environmental rules, and proper sequencing. By dividing the work into two phases, we reduce unnecessary hauling, reuse acceptable soil, controlled contamination risk, and kept foundation construction coordinated efficiently.